Okay, so I'm going to tell you a story about this guy right here. So we're going to say that this guy, he likes girls, okay? So he is going to ask these girls out on a date, okay? So let's say you ask the first girl and she says no, okay? And let's say she asks the next girl and she says no. And let's say you ask the next girl and she says no, okay? What is the probability that this girl's going to say yes, all right? Let's take a different guy over here. Okay, I'll draw this guy over here. Let's say you ask this girl on a date and she says yes. He asks this girl on a date and he says yes. He asks this girl on a date and he says yes. She says yes. Now, what is the probability when he asks her that she's going to say yes? So, do you think he has a better chance of getting a date with this girl, or that he has a better chance of getting a date with this girl? So, the answer is we don't know. Depends on the way you look at it. Maybe this girl says, that guy's a slut. Look, he's gone out with all these different girls. No way I'm going to go out with him. Or maybe there's a reason everybody says no to him, and there's a reason everybody says yes to this guy, and he's really good looking, has it all together, and this guy has some serious hygiene issues or something. So he definitely still has a better chance. We don't know. We don't know. And so this is a question that we could ask ourselves, and it has to do with independence. Okay? When we say independence, we're talking about events occurring, so the probability of an event occurring, we ask ourselves, does some previous event, so does a previous outcome influence a future outcome? So let me give you an example. Okay, let's say that I am going to say that here are all the kids in the school, right? Some are boys and some are girls. Okay, and we ask them whether or not they have a job. Okay, and let's say that that some say yes and some say no. So this is what we call a two-way frequency table. We're gonna do a count here. Okay, so let's say I ask the boys, how many of you had a job? Well, let's say that 5 boys said yes and 10 boys said no. And let's say we ask the girls, and the girls say, I don't know, we'll say there's 10 yes and 5 no's. So girls in this case have more jobs than boys for some reason. So the total, here's the total, we have 15 that have jobs and 15 that don't. So we're going to just say, let's define A as, if we pick a student at random, what is the probability that they say yes, they have a job? And let's define event B as being that the person is a girl. Okay, so now let's circle our subsets. So what we're asking ourselves is, at first, all of the responses that are yes are in set A. All of the responses that are no, or that are girls, all the girls were asked, is set B. So now we're going to ask ourselves this question. Is the probability of A equal to the probability of A, and then see this line right here? B. So that line right there, that's a vertical line. It's meant to be drawn vertical. It's not a slash. It's not A slash B. It's a vertical line B. So what this means, it means given. Okay? And when we get into conditional probabilities, we'll learn a little bit more. We'll talk a lot more about this. But if we were to say that A given B has occurred, what would the probability be? Well, what is A given B? Well, the probability of A, let's just do the probability of A. The probability of A is everybody who said yes, and that's 15. So the probability of A, well, let's actually write this out the way we were taught. So we go, probability of A is equal to the number in A over the number in the set. So the number in A was 15, and the number total in the set was 30. So the probability of A is 1/2. Probability of A equals 1/2. Now let's do the probability of A given B. So this means that we've already gone through the group. The given part means this event has already occurred. So they're just coming along and they're saying, okay, hold on, we've grabbed all the girls. We already did that. We just grabbed all the girls. That part is done. So given that it's gonna be a girl, what is the probability that they say yes? So really all we're doing with a probability like this is that we're saying, okay, it's not a boy. We can just cross those guys out for a moment. And we're asking, what is the probability of A, if I cross those out for a second, kind of like this, what is the probability that I got a yes out of this sample space only? Now my sample space consists entirely of girls. That's what this means. I'm only going to look at the girls here. So what was the probability that A happened given that B happened is equal to the number in the set A given B over the number in B, right? Just in B, because B is what has already occurred. So what do we have here? That's equal to, well, there are 10 that said yes out of a total 15. So this reduces to 2/3. So now we ask this question, are these equal? If the probability of A is equal to the probability of A given B, if they are equal, then, so we go, if these are equal, then the events or the outcomes are considered independent. Okay? If the probability of A is equal to the probability of A given B, then the events are independent. The fact that B happened won't change the outcome of A. Doesn't matter. But if we would say the probability of A does not affect or does not equal the probability of A given B, or rather, since B has happened, it has now changed the probability of A, then the events are not independent. Okay, that is an overview of independence. We would have to really kind of look at this table. This is what we call a two-way frequency table. We have to understand conditional probabilities, which is saying, okay, given a certain event has already occurred, now what's the probability? Okay, and then we're going to do a little test to see what is the probability equal to determine whether or not the events are independent of one another. Because independence is going to affect, whether or not they're independent will affect our calculations for probability. And we'll see that here in a moment with some Khan Academy exercises.